Okay, so here we have an iGCSE question, a classic problem-solving kind of puzzle, very simple diagram and a description. And before we tackle this problem where we have to find the angle CDB, so CDB, this angle here, let's have a look at the examiner's remarks. So the examiners say that students didn't do well on this question. The challenge was to find a suitable way to link the angle at D, this angle then that we're trying to find, with the angle at A. So we've got to somehow get from here, the known angle, to here, the unknown. It was particularly disappointing to see so many students who thought that angle DBA was 90 degrees. So the angle at the top here is not 90 degrees. They scored no marks. A common error was seeing the triangle ABD as an isosceles triangle, which led to an answer of 29 degrees. Okay. So let's have a look at this problem and see if we can solve it. And I can think of a couple of ways of making an inroad here. One thing I want to do before I actually start working on the diagram is look at the description, because sometimes the description adds information that we need to add to the diagram. So let's just check the description before we just work on the diagram. So A, B and C are 3 points on a circle, so A, B and C, we've got those marked. DCA is a straight line, okay, that looks correct. CA is a diameter. Now here's the extra information. So CA is a diameter of the circle, and that means that AC, and going all the way around here, if that's a diameter, it's bisecting the circle, so this must be a semicircle. And that gives me an idea about how to solve it. Let's just complete the description. DB is a tangent to the circle, so we've got our tangent here, and it says calculate the size of CDB. Right, now what I'm going to do is join B to C. It seems an obvious thing to do, and what I'll create is an angle in a semicircle, which I know is at 90 degrees. So that's going to begin to fill in this part of the problem, helping me to work towards this. Before I do that, I'm actually going to turn my paper upside down. And the reason why I like to do this is because sometimes you can see something upside down that you couldn't see up the right way. So let's turn the paper up the other way as well, so we can see it from this angle as well. And yes, in fact, that already helps, because if I join C to B like that, I can see the classic shape of the alternate segment theorem. So now let's try and fill in some angles. So first of all, if I've got the alternate segment theorem on my mind, let's work on that first. So I've got the triangle in the circle, an angle in the first segment, so in other words this angle here. Let's just get the correct pen. Okay, this angle here must be congruent with this angle here, because we are talking about the alternate segment theorem. So I'm going to write down, in a minute I'll rub this out because then we're going to have to turn it upside down, but let's use this space here. So angle CBD, okay, we can say is 32 degrees. We're not actually asked to give the reason, but if I were to give the reason, I would say it was the alternate segment theorem. Okay, now from there, knowing this is 32 degrees, I might also want to get this angle here. For that, I need to know this angle, and as I said before, this is an angle in a semicircle. Angle in a semicircle is always 90 degrees. So we've got a 90 degree angle there. So now we know that angle, what's this? Well, we need to give this another letter, so we call this angle EBA is going to be 180, because its angle is on a straight line, 180 degrees minus 90 plus 32, so that's 122 degrees. So that's the same as 80 minus 22, which is 58 degrees. you might want to just check your arithmetic if you're not sure. Adding back 100 plus 50 plus 20 gives us 170. 8 plus 2, 10, so that's 180. Confirming that 58 belongs there. Okay, now from there, I can also fill in angle BCA. In fact, I could have done that straight from the right angle here, I now realise. So I could use the three angles in a triangle sum to 180 degrees, but I can also use the alternate segment theorem again. So this must be 58 degrees here. Alternate segment theorem. But I just want to check that by, let's just use a different pen, by making sure that these do add up to 180 degrees. So we've got 58 plus 32 plus 90 should add up to 180 degrees. So 58 that's and 32, that's 80, 90 degrees there. So we've got 90 plus 90 equals my 180, so that's good. That's confirmed that this must be correct so far. All right, how does that help? Well, we've got angles on a straight line again up here. So we've got DCB. DCB must be 180 minus 58, which is 22. So this has got to be 22 degrees in here. So we'd need to write DCB is 22 degrees. And so we're nearly there. We now need to just use the triangle sum theorem. So we say that angle BDC, which is what we're trying to find. Okay, they call it CDB, so we'll call it CDB as well. CDB is going to be 180 minus the other two angles. So minus 32 plus 22, giving us 180 minus 54, and 180 minus 54, is that right? 180 minus, now what have I done here? CDB is 180 minus, this can't be right, can it? 22. How did I get 22? DCB is 22. No, 122. Okay, so there we go. At least I've realised my mistake. So that should be 122. That should be 122. So easy to correct that mistake. We've now got, let's just rub this out then. Let's recalculate. Okay, we've got 32 plus 122, that's 154. That sounds better. 154. So you can tell often when you make mistakes like that because they just look ludicrous. Okay, 180 minus 154 gives us 26. Okay, so my answer is that angle CDB must be 26 degrees. Well, okay. That's got an answer, and it's an interesting way of doing it, but I'm going to do it another way, which will give me a second check actually to make sure 26 degrees is definitely the answer. But it will also show, hopefully, that there's more than one way to skin a rabbit, as they say. Okay, so let's erase all the ink. Let's just erase that line, turn the sheet back up the right way, and think of it in a different way. Well, I said that the important bit of information was this idea that CA is a diameter, and I'm going to use that idea again, but in a different way. Okay, so this time what I'm going to do is give us a center for our circle. So the midpoint of CA must be the center of the circle, and let's label it 0 or O. So now we've got the centre of the circle. Let's join B to O. So angle BOA is what I'm after here. Okay. Now, if I join B to O, like this, okay, then what can I get first? Actually, OBA is what I want to get first. All right, so let's do angle OBA. OBA. Well, that must be 32 degrees, because now we've got an isosceles triangle. We've got two radii. Those two radii make up this isosceles triangle. So the base angles of an isosceles triangle are congruent. So this must be 32 degrees. And that means that this angle here must be, what's that, AOB, must be 180 minus 32 plus 32, which is 180 minus 64, giving us 26 degrees. Okay. No. 116 degrees, sorry. 116 degrees, jumping ahead there. 116 degrees. So this angle here is 116 degrees. So we've got all the angles now of this triangle. Okay, how does that help? Well, we know that this angle here is 90 degrees. So let's just mark that on 90 degrees. And we can get this angle here, which is 180 minus 116. So let's write that down. DOB, angle DOB is 180 minus 116, angles on a straight line. So that gives us 64 degrees, this angle here. So now we've got two of the three angles of the triangle DBO. So what I'm going to do is now call this not ODB but CDB. So therefore CDB is what's left when we've added the 90 to the 64. So this angle is 90 degrees now. So it's 180 minus 90 plus 64. And hopefully this will come out at 26 in the same way as we got that answer last time. Let's have a look. 180 minus, well, if I add 10 to that side, subtract 10, I've got 154. And so 180 minus 54, same as 80 minus 54, is 26 degrees. And because of my check that I did before, I know that that must be correct.